then, it's like 11:10. I don't want anybody to miss anything just because this, mess up. I guess I am recording it though. And it's Friday, notorious low attendance day anyway. $13 of you out there. Yeah, so right now, okay. So guys, yeah, when I start the lesson, I'll be sharing my whiteboard screen. And so you extended students, you won't actually see me or the class. All you'll see is the whiteboard. Actually, I might as well do it now to show you what it's going to be like. So I'm going to share screen, whiteboard. So it'll be like this. I'll go ahead and hide all that good stuff. I'll make it large. I don't know what that is, but I would like it to go okay. Something about the smart board, which I am going to have to know how to control today. So yeah, so what you guys should be seeing now is just the whiteboard. And this is what it'll be like in class. Move some things around so we have space. And hopefully it is a responsive pen and you can actually understand the things that I'm writing. And for you guys, you can see here or there or wherever you want to look. And I guess I'm going to get started. I feel like I'm talking to nobody because I can't see them now. My whiteboard. But yeah, so maybe it's just the four of us in here. Honestly, I could see like somebody coming to class, them saying, oh no, it's another building, and then they just don't come. I might have done that. All right, so here we are starting the lesson. So guys, this is going to be a lesson 4. Oh guys, I'm sorry about this. We are going to, oh, this is the worst pen that ever existed. Sorry. I will try to say words loud so you don't have to rely on my writing. We're going to take derivatives. Yeah, I know, you can't read what that says. It says derivatives. I'll work on it. Maybe I'll get better as we go. So what a derivative is it's a variation of instantaneous rate of change. So remember when, I say remember like it wasn't 2 days ago. Remember 2 days ago when we were doing instantaneous rate of change, and let's say I had a function, just any random function. I picked a point on that function, and I calculated the instantaneous rate of change, which was the slope of the tangent line at that point. And yes, last time I took that slope, and then I went further than that, and I found the equation of the tangent line. Do you think it's fine? Like, can we? I know you can. Like, I think it's fine unless you guys are like super worried. But like, this room is large and echoey, and I feel like, it's totally up to you. I'm like way far away from you guys. So, anyway, so we took that further. We found the slope. And then we already had a point that we had found by calculating the IROC. And what we did was we found the equation of the tangent line. So basically all of that work, which was quite a bit of work, to find the slope and or equation of this one tangent line that only applied to this one point on the function. If I moved this point just even a little bit down to here, that would be a different tangent line, and all the calculations I just did would not apply. So it seems like a little bit tedious, right? Because IROC was really tedious. So let's remember what we had, and I'm just going to change one thing, and it's going to make it a lot more efficient. So we're going to have the limit as h approaches 0, And remember, you guys know this one. We've got f of a plus h minus f of a all over h. So that's what we know. But remember that a value. Now h is always h. But remember that a value, I had to tell you what to put in there. So like this point here, maybe I said this is the point where x equals 1, for example. So you would put a 1. You would put a 1 in for these a values. And then we calculated, and yes, it was tedious, but we got there and, you know, we felt good. So what I'm going to do is, because this only works for a specific point, what if I made it more general? What if I didn't pick a point for x at all? What if I just said for any point on the graph? Instead of putting an actual number in for a, here's what I'm going to do. This is going to be the limit as h approaches 0 of f of x plus h minus f of x over h. So all that I changed was I took this a, which stands for just a constant number, and I replaced it with x's, because x's are general. This is like a general version of this. And it says that I can now calculate the change or the slope of this tangent line for any value of x, because I didn't tie it to a point. I just left it as x. So this is what I'm going to use today, and this is what we call the derivative. So let me see if I can write it. I have to pick up my pen more. This is the derivative of the function, which I know usually we call it f of x. That's what I've called it here. So if I say find the derivative of f of x, what you're going to do is you're going to use this formula here, which looks a lot like the formula we already used, but with an x in place of the a. All right. So before I move on, extended class, could just like somebody unmute themselves and like sound out that you guys can see and understand what I'm writing and saying?
Yeah, 100% we can hear you.
Perfect. Okay, cool. This room's weird. You're not here to see it in person, but just take my word for it. So here we go. Let me erase. That is kind of easy. So you guys, we're going to use this in an example. So I'm going to give you a function. Let's say f of x equals x squared plus 4x minus 3. And I want you to find the derivative of f of x. So find the derivative. But you guys, I'm not going to write it out in words every time. You know, I'm not going to always say find the derivative. I can't believe there's only 4 of this. Anyway, we have notation for that. So when you're in function notation, so when your function is written as f of x, and I want you to find the derivative, the way I'm going to notate it is this way. So it's like a little tick mark or an apostrophe on the f. It's not, sometimes if I get sloppy, so everybody coming in, yeah. Yay! We got another student that found their way over here.
Thank you.
Hi.
Oh, hi there.
Oh, 2. Yay. We were like, we only have 4 people in here. Yeah, sorry. I took this off because I'm way far away from you.
So if you all have y'all maybe to start writing the notes and stuff?
We started about 3 or 4 minutes ago.
Oh, okay.
So yeah.
Did we miss anything else? You know, the first one though.
There was so I wrote like a screen's worth of stuff that I just erased and I started this. That could be something because they're recorded. If you need that screen, like if you're working on stuff, you can always go back and watch just like the very first part of the video.
Okay.
But honestly, we're gonna like it should be fine. Okay, guys. So what we're doing is we're finding the derivative, and we I told you a formula that can find this value called the derivative. So we're gonna find it. So this f with the little tick mark, a lot of times I'll just say this is the derivative of f of x, or I might say f prime of x. That's another way to say take the derivative. F prime like first, because later on we're gonna see that you can take the first derivative, second derivative, third derivative. Right now we don't have to specify because we're only taking the first. But if I say f prime of x, I mean take the first derivative. So how do I find it? Well, I use that formula I just gave you that looks a lot like the other one that we had. So we're going to take the limit as h approaches 0. Remember up here, instead of f of a plus h, we're leaving the x in. So I have f of x plus h minus f of x all over h. So remember, leaving the x in, not tying it down to a single number, will give us a general form for the change that I'm looking for. It's not going to be tied down to one specific point anymore. So this is what we're going to use. Now, leaving the x in there as a variable means I have another variable in my calculations, which means I might have more expressions, more terms in my expression. So let's see what happens. Remember when I'm using this formula, the old one, I started by taking this over to the side. I said, hey, well, let's find f of x plus h. So f of x plus h is found by going to your original function. They can't see me pointing. Going to your original function and putting x plus h in where there's an x. So using parentheses, I have x plus h squared plus 4 times x plus h minus 3. Very similar to when we put a plus h in there. Okay, so x plus h squared, x plus h times x plus h, plus, let's go ahead and distribute this 4. So plus 4x plus 4h minus 3. Let's FOIL that x plus h term out. So x times x is x squared. X times h is plus xh. H times x, that's plus xh again. And then h times h is h squared. And we still have, even though I'm running out of room, we still have plus 4x plus 4h minus 3. All right, so once you're here, you've FOILed everything out. Notice that you can do xh plus xh, and you call that 2xh. So then I have x squared plus 2xh plus h squared plus 4x plus 4h minus 3. But after we combine those xh terms, notice there's nothing else I can put together. So f of x plus h is often larger than f of a plus h was, because a was just a number, and what happened was we had a lot of constant numbers here that we could put together. But we don't have that anymore. So this all is going to be put into our formula. So let's do that. So this is the limit as h approaches 0 of this big thing. So in place of f of x plus h, we're going to put the x squared plus 2xh plus h squared plus 4x plus 4h minus 3. So I subbed that in. Now, what about this minus f of x? We used to have to put in a value and find a number here. But if it's just asking for f of x, isn't f of x just given right here? So that's what I put in. It just wants the general form of the function. So make sure that you put this in parentheses because it's multiple terms. But minus, in parentheses, x squared plus 4x minus 3. And then on the bottom, I have that little h. this? No. Okay, so we're here. At this point, remember when we were doing the instantaneous rate of change? At this point, if I started canceling things, and I said that if everything that doesn't have an H that's up here, it should cancel, right? And if that's not the case, then we've done something wrong. Well, even though this has more terms in it, that's still what's going to happen. If you have terms up here that do not have H's in them, they should cancel out right here. So let's see if that happens. So I have x squared. Remember, this distributes, so this is minus x squared. So we're here. What about this plus 4x? So I have plus 4x. This also distributes. This is minus 4x, so it's gone. And then we have the minus 3, but this distributes too, and makes that a plus 3. So I have a minus 3 plus 3, and that's also gone. So let's see what's left. So I have the limit as h approaches 0 of 2xh plus h squared plus 4h. That's all that's left on top. And on the bottom, of course, I have h. Now I can do the thing, right? Now I can take care of the h's because everything has an h. So let's cancel h's out of everything. And when I do, I'm looking at the limit as h approaches 0 of just a single term, not a fraction anymore, 2x plus h plus 4. That's all that's left. So now I can take the limit. I can put h equals 0 into my function. And what is left? Well, if h equals 0, then that just takes an h away. And what's left here is 2x plus 4. So look at the difference between your answer here and the answers you always get on instantaneous rate of change. Every time you did an IROC calculation, your answer was just a number, like 5 or 7 or -2 or something like that. Yes?
Why'd you cross out that last H again?
So I took the limit, so
They put in 0.
I plugged in
Okay,
0,
makes
yeah.
sense. Okay.
Yeah, I plugged in the 0 here for that H.
Okay.
So yeah, our IROC calculations were always single numbers, but remember that's because it was giving me the slope of a tangent line at a certain point. So I said, ooh, at this point, what's the slope of this specific line? And it said, oh, it's 2. So that makes sense, but I'm not asking for a specific line. This calculation gives me the slope of all tangent lines to every point on the function. All I have to do is pick a value for x, stick it in here, and it's going to give me the slope for any value of x. So, example. Let me erase a little bit. So let me give myself some working space. All this monstrous. Okay. So let's pick our derivative we just found. So what we just found was that f prime of x, or the derivative of f of x, equals 2x plus 4. Now, from there, if I asked you, what is the instantaneous rate of change, or what is the slope of the tangent line of this function of f of x at x equals 2, you're like, hey, you just had me do all of this math, and now you're asking me to do it again using the instantaneous rate of change formula? But do we have to? Absolutely not, guys. If I have the derivative, I can find the instantaneous rate of change, i.e. slope of the tangent line, for any point that I want. All I have to do is take this x value and plug it into the derivative. So let's do that. Another way of writing that question without so many words is I could ask for the derivative of f of x at 2. I could write it like this, like f prime of 2. Yes?
So instead of doing all these steps, like can we do the easy method also, like to find what that prime of that solution is?
Not yet. We will, but you can't use it yet. you have to drudge through the mud
Uh-huh.
so you can get to the easy way. But you guys, this is another way of asking the question. I could just write this, and when you read this, you're gonna say, okay, I'm gonna find the derivative, and then I'm gonna evaluate it at 2, finding that IROC of 2. So you're gonna do 2 times 2 plus 4,
8.
yeah. So you got 8, so that's saying that if you had taken the function from the beginning and found the instantaneous rate of change at x equals 2, like putting in a 2 for the a in that function, you would get 8. This is the slope of the tangent line at x equals 2. But maybe I want to find a different spot. I want to find this time at x equals -1. So do I need to do any kind of formulas over again?
No, all you just have to do is plug in that number for the value of x.
Right, so instead, I'll take the derivative that I just found and plug in a -1. Get -2 plus 4, that's gonna just be 2. So what's the slope of the tangent line for this function at -1? It's 2. So this is what's nice about the derivative. You do a little extra work at the front of the problem. All of this, because we had a lot of terms, they didn't really cancel each other out. We just had this large set of terms that we had to deal with carefully because mistakes are easy to be made on a problem like this. But once we actually got to the answer, it's really smooth sailing because you can put in whatever value of x you want. You never have to do that limit calculation again, for this function at least. Okay, so this is the derivative. We're going to do another one. Okay, so the thing about this calculation, again, is it's a little more time consuming. You do more work on the front end, so you can have it easier time later. But I'm going to do another one. This one I'm going to do a y equals. We've been in function notation for a long time, probably since algebra. Yes?
Can you go a tiny bit slower?
Yeah. It's probably the problem that I'm clearing it all at the same time, right? Is that a problem, like you don't have time to
Yeah.
copy it down? I worried about that after I pushed clear all, and I was like, that was fast. I will try to.
At least it's
So-
recorded.
And it is recorded, you can always look at it later. So guys, function notation, we've been using it for a while since like algebra, and we know what f of x means. But remember, when you started using function notation, you replaced y with f of x. And sometimes your functions are gonna be written in the xy notation, just to throw it at you, throw something different to make sure you can handle it, basically. So instead of f of x equals, this time I'm going to have y equals. And I'm just going to do y equals x cubed plus 2x. That's my function. Now I can't ask for f prime of x because this isn't in function notation. So when I ask for the derivative here, all I'm going to do is say find this. So notice it's the same, little tick mark. I still say prime, I say find y prime, or the derivative of y. This is another way to ask the question. Anytime you see that, you know you're just going to use the derivative. So what is the derivative equal? Well, it equals the limit as h approaches 0. Now it's a little harder to think about how to write out the formula when it's not in function notation. What I would do, because you can't really write f of something because we don't have a function f, what I would do is go ahead and find those values, like f of x plus h. You can find that to the side, and then just put it in here, if that makes sense. So I am going to write this because we're trying to remember this formula. But it doesn't really apply to our situation because I'm in y. But that doesn't mean I don't have to find this function evaluated at x plus h. So let's see what that would be. So evaluate this at x plus h. Everywhere there's an x, replace it with an x plus h. So instead of x cubed, I'm gonna have x plus h cubed. And then I'll have plus 2 times x plus h. So this is, like I said, this is bad form, but this is why evaluated at x plus h. That's still what we're looking for. Now, the f of x part, even though it doesn't make a lot of sense, remember that's just the original function. So we have to find this now. And it doesn't seem like much of a leap from the one we just did, but going from squared to cubed definitely adds a lot of terms. So let's do this. You guys, x plus h cubed is x plus h times x plus h times x plus h. And then we can go ahead and distribute this. Let's call this plus 2x plus 2h. So foiling still going to happen here, but what we're going to do is we're going to FOIL these two terms together, just like we would in the other problem. We're just going to square it first. Then once we get this done, we're going to multiply it by this one. So we're going to basically FOIL twice. So I'm going to need some space, so I'm going to start over here. All right, FOILing the first two terms, super easy, right? We've been doing this. X times x is x squared. You guys notice that we're going to have x times h and then x times h again. So again, we're going to have plus 2xh. And then h times h is h squared. Put this in parentheses. Because remember, you have to take all of this and multiply it by that last x plus h term. Now, the easiest way to do this, I would say, is start with this x here and distribute it to every term over here. So like do this. And then go to the h and do the same thing. Everything over here multiplied by everything over there. So let's do that. So start with the x. X times x squared is x cubed. X times 2xh is plus 2x squared h. So all I did was multiply by a factor of x. And then h squared times x is just h squared x, or xh squared. It doesn't matter how you write that. Now do the h. So now we have to multiply everything times h. So h times x squared, that's another hx squared term. Or, ooh, guys, let me switch the order of that so it looks like the other one. So you guys, I'm going to write that as x squared h because I have a term that already is written that way. So let's call this x squared h. So now take the h times the middle term, so h times 2xh is going to be plus 2xh squared. And then lastly, h times h squared gives us plus h cubed. Don't forget, sometimes we do all that and we forget we have those other terms, the plus 2x plus 2h. So this is a lot. And notice the subtle differences between terms are just that they are subtle. So x squared h and xh squared look a lot alike. So we really have to be careful and make sure we don't try to clump those together. So guys, let's combine like terms. There's just one x cubed, so x cubed. But what about x squared h? I have two x squared h's, and then I have plus one more x squared h. So that's 3x squared h. And then let's talk about h squared x's. There's one. Here's one. Look, I wrote them in a different order again, but these are the same, right? Because they both have an x and they both have an h squared. So I can put these together. Be careful. So I can say there's 3, let's call it xh squared. So guys, the h squared x here, you could also write that as xh squared. That would make it more similar, so you can see that better. But it's the same term. And then we just have plus h cubed. And we just have plus 2x and plus 2h. So we're here. We can't combine anything else. This is f of x plus h, or in this case, it's y evaluated at x plus h. But we're not done, even though we want to be done because that took a lot of work. We now have to stick this into the limit formula. So I'm going to let this sit tight for a minute, make sure we get it all down because I am going to have to create space over there. And you guys, this is a long problem and it will be once we're done with this problem, we'll be done for the day. Which means total, we've done 2 problems today, but that's just because they take a while. So let's see, can I take away like this top line here? Like, can I do like these 3? And we're all good there? So I'm gonna take these 3 top lines away. I'll leave those 2 bottoms. Okay, all right, so here's what I'm gonna do. I'm gonna take the problem up here. Remember, I'm looking for this derivative. It equals the limit as h approaches 0 up. Need like all of that space, right? Because here is where the x plus h term goes. I don't know if I'm going to be able to fit it there. We'll see. All right, so it's going to be the x plus h minus the f of x term, or the y in our case, over h. Okay, so let's put all this in here. We have x cubed plus 3x squared h plus 3xh squared plus h cubed plus 2x plus 2h. Sorry, that's a little hard. I was trying to write it small. And then minus. Remember, that's just minus the original function. So minus x cubed plus 2x. Now, what should happen here is what happens every time. Everything that does not have an h in it should go away from here. So let's see if that happens. You guys, I have x cubed minus x cubed, so those do go away. What else doesn't have an h in it? This 2x? Does it go away? Yeah, because that's a minus 2x. Another thing that you can easily check, once you do that canceling, basically everything in your original function over here cancels out, is what's happening here. All right, so let's see what we have left. Okay, so on top we have 3x squared h's. We have x h squareds. We have an h cubed and we have a plus 2h over h. So now's our chance, guys. We get to take all the h's away. So let's do that. 1, 2, let's take this one down to h to the first. You guys, this h cubed is just going to become h squared, and then this h will go. So let's see what we have left. So we have the limit as h approaches 0 of 3x squared plus 3xh, just 3xh to the first, plus h squared plus 2. Oh, guys, I just took that h away. Sorry. That's what we have. We want to take this limit. How do I take the limit? I set h to 0, right, in this whole term. So let's do that. Let's see what we get. Well, if h is 0, if I'm putting in a 0 for each h here, then this term goes away and this term goes away, because h is 0. All that's left is everything that doesn't have an h. So I get 3x squared plus 2. You guys, this is the derivative of that function x cubed plus 2x. What it means is that if I pick any value of x I want to, I can find the slope of the tangent line at that specific point. So, yeah, we do have to stop here though, because I actually have to book it all the way back to math for my next class. So, I'll leave this up for a little bit while I close things down. Guys, you have a quiz that's due on Sunday night.
Sunday night?
Sunday night, yes.
Oh, okay, well, when I checked the deadline, it showed like the future now, so that.
Oh, it did?
Yeah, that's kind of weird though.
I'll check it again, you guys, that quiz, if it says it's due any other time, I will check and fix it, it's just Sunday night,
Okay.
definitely Sunday night, guys. Which is also your homework due. On the quiz, what you're gonna find is questions that look just like your homework questions. The only difference being you can only do them one time. You know, you don't have unlimited attempts on a quiz. So my suggestion would just be to finish your homework first and then take the quiz because you'll be ready for it. I cannot govern what you have or what you use on this quiz. I can strongly encourage that you use notes you take in class. That's all I would normally allow. So, you know, just honestly, if you use other stuff, you're just cheating yourself, right? I mean, if you let the computer do it for you in some crazy program, they're not really that crazy. There's a lot of programs out there. I'm not gonna tell you what they're called. But just do your best and try to, because when we take an exam, I'm actually gonna have you turn in your work to me. So because you're gonna have to be able to work it out on your own for a test, you might as well practice that now. Yes,
So for this quiz, are we required to show work and stuff and turn it in, or?
you don't have to turn in work for the quiz. It's so short and that's just a lot of time, you know, for a little quiz. But the test being worth so much more, definitely that's when I'm gonna want that. Yes,
Will we have a limited amount of time?
yes, unlimited time, guys. There's no time limit on your quizzes or exams, actually. So, I mean, it's probably not gonna take you very long, but if it does, I mean, who's to say that's a problem? You know, I don't care how long it takes you. So yeah, that's it, guys. I'll see you not here. I'll see you, you know, on Zoom on Monday.
Alright.
And because I know we have a lot due on Sunday, I'm available. Email me anytime if you need help on over the weekend even.
What's your name?
It's,
What do you major by the way?
I'm doing international business.
International business. Sorry.
All right, I'm gonna stop sharing the screen. Everybody's good with that in the Zoom meeting.
It's not.
Oh, nice. Where are you from?
Right, Oklahoma.
Oh.
All right, guys.
That's your.
Into this meeting, so I'll see you guys in a day.
Yeah.